Hey guys, another Chapter 5 video here. We're doing 5.2 in our textbook if you're in our class. Essential question is, how can I use the substitution method to solve? So substitution is a way of getting around having to graph. We already know what a system is. A system is when you have a graph with two or more lines on it and you're trying to find where do those lines cross, where is the point of intersect. So if you're looking for the point of intersect, graphing's great, but you don't always want to graph. You want some other methods, and that's where substitution kind of comes into play. Let's look at some examples. We're going to try a problem here. So first problem, example 1, is going to look like this. We're going to solve this system. We want to know where these two lines cross on a graph. The first line is y equals negative x minus 7. And the second line is 5y plus 3x equals negative 13. Answer. Stop it. 3. Alright guys, example 1. Here we go. We are going to solve this system. We want to know, on a graph, where do these two lines cross? The first one's y equals negative x minus 7. And the second one is 5y plus 3x equals negative 13. Go ahead and write those down. Now I'm going to solve this without graphing. I'm going to use that substitution method, which I have a little nickname for, so I'm going to put a little thought bubble over here to the side, which you can put in your notes also. I like to call this the bubble method. I call it that because I'm bubbling variables. Bubbling means I'm circling them. I'm always looking for which variable is all alone, all by itself and isolated. And in this problem, it's the variable y, because we have y equals negative x minus 7. That y is all alone. And what I like to do is in the second equation, find the matching y. What I know is y and negative x minus 7 are equal to each other. They're the same thing. So what I can do in the second equation is I can take that y, because they're equal to each other, and I can replace it. And that's my plan. I'm going to replace it. Now I'm going to need a little more room to work, so I'm going to clear up my screen here. Here's what we're going to do. Instead of having a 5y plus 3x equals negative 13, we're going to have a 5 parenthesis plus 3x equals negative 13. And inside that parenthesis, we're replacing the y. We're substituting. Remember, if like I had a substitute teacher in class, that means somebody comes to class and replaces me that day because I had to be out sick or something. Same thing. I'm going to replace the variable y with negative x minus 7. Because they're equal to each other, they're equivalent. We just figured that out. So instead of 5y, I have 5 parentheses negative x minus 7 plus 3x equals negative 13. And now I can solve for x. I see parentheses, I see distributive property, so I'm going to multiply that 5 in right away. I'm going to do 5 times negative x and 5 times negative 7. It's going to be a negative 5x and a negative 35. And then I still have all the other stuff, the plus 3x equals negative 13. Put my line down the middle, times solve for x. So I'm going to add 35 over, get that out of the way. That's going to leave negative 5x plus 3x. And then negative 13 plus 35, that'd have to be 22. Then I'm going to combine my x's together. Negative 5 plus 3 is negative 2. So I have negative 2x equals 22. I'll divide the negative 2 away and I'll be ready for an answer here. X is going to equal 22 divided by negative 2. That's negative 11. And there's our solution. So if I was to do my graph, I would have to go out to x equals negative 11 to find my point of intercept. Kind of glad I'm not graphing. But I'm not totally done. I don't know the y coordinate, so I still need to solve for y. To solve for y, you got to go back and pick one of the equations, either the first or the second. The first one's going to be the easiest because it was y equals negative x minus 7. But now I'm going to change my x to my answer, which is negative 11. So instead of that negative x minus 7, I'm going to have negative 11 minus 7. Notice the double negatives. You got to pay attention to the symbols. It was negative x, so now it's negative 11 minus 7. And that negative is going to turn into a positive 11. So we're going to have 11 take away 7. And that means y is going to equal 11 take away 7. Well, we can combine that. That's 4. So we got our answer. Y is equal to 4. That's our second solution. So let's take a step back. Let's look at our work now. Here is all of our work. We now know the point of intersect is at negative 11 and 4 on the graph. I can box that as my final answer. And notice if you look at the whole picture here, I'm organizing my work as best that I can. I'm doing a lot of algebra, a lot of solving for x and y. There's a lot of math going on here. But I'm trying to do it in a way that like a stranger could grab my paper, look at it, and understand what I'm doing. So I'm trying to be neat and organized. That's always super, super important in algebra. Let's try another problem. I'm going to show you kind of a weird case. Oh wait, same direction. Solve this system. I want to know, where does y equal 7 minus 2x intersect and cross on the graph with 2x plus y equals 10. But I'm going to use substitution, bubble method. I see the y all by itself, so I know it's equal to 7 minus 2x. So in this second equation, I'm going to find that matching y, and I'm going to replace it. I'm going to be replacing that y with the 7 minus 2x, because they're equal to each other. So instead of 2x plus y equals 10, I'm going to have 2x plus 7 minus 2x equals 10. Awesome. All right, now I got to solve. Normally I'd be thinking distributive property, but I don't really see anything I need to multiply into the parentheses. So let's forget about the parentheses. Let's just write 2x plus 7 minus 2x equals 10. And then we're going to get that 7 out of there. Take the 7 away. That'll get it out. Now I still have 2x minus 2x, and then I have 10 take away 7 is 3. Now here's where it gets weird. What's 2x take away 2x? 0, nothing. So I have 0 equals 3. Does 0 equal 3? No, not in our world. I'm going to slash out that equal sign. So the question is what's x? What does x equal? Well, it's gone. X is gone. 0 doesn't equal 3. Doesn't make a lot of sense. So I guess in this problem, x is no solution. What does that mean? That means if I graph this, they don't cross. There is no point of intersect. There's no solution. What do you think y is going to equal if I tried to solve for y? Well, I can't solve for y. It's no solution too, because there's no point of intersect. Kind of a weird case, right? I thought it doesn't happen very often, but it's nice to kind of see some of these weird cases. Okay, for this part of the video, you can put your pencil down. You don't need to write this down, but I want to kind of quiz you here for a minute. And the question is how would you bubble this? So I'm going to give you a problem. The question is what would you bubble? What would you circle to do your substitution method? Think about it for a minute before I show you the solution. Okay, so when I go to bubble, I always look for the isolated variable. In this case, it's y. Y is all by itself. Y is equal to 6x minus 3. So the first equation, I circle and bubble the matching y. That's how I would set up this problem. I hope that's what you were thinking in your head too. How about this one? I'm going to show you another one. What would you bubble in this problem? Right away, I'm looking for the isolated variable. In this problem, it's x. X is all by itself, and it's equal to 15y minus 2. So in the bottom equation, I'm going to bubble the matching x. They're equivalent to each other. All right, your turn. Pick that pencil up. I'm going to give you a you try problem. Here are your directions. Solve this system. Where does x equals negative 3y plus 1 intersect 4x minus 3y equals negative 11? This is where I want you to hit that pause button on your screen. See if you can solve this all by yourself, and then unpause it when you're ready to check your answer. Okay, so you've paused the video, you're unpausing, you're all done with your work, and you're ready for checking your answer. Here's what I'm hoping you did. You noticed x was isolated, all by itself, and it's equal to negative 3y plus 1. So in the second equation, you're replacing the x with negative 3y plus 1. I'm going to put a little arrow. I'm going to replace it with negative 3y plus 1. And instead of 4x minus 3y, I now have 4 times negative 3y plus 1 minus 3y equals negative 11. Now I can solve. Definitely distributive property. Got to multiply the 4 in. 4 times 3 and 4 times 1. So 4 times 3, it'll be a negative 12y plus 4. And then I still have the minus 3y equals negative 11. Get the 4 out of there to the other side, and you still have negative 12y minus 3y. Negative 11, take away 4 is negative 15. Let's put the y's together and make that negative 15y equals negative 15, and we're almost done now. We're going to divide the negative 15 from both sides, and y is going to be 15 divided by 15. Y is going to be 1, positive 1. There's our solution. I hope that's what you got too. Now we're not done. We've got to solve for x. Don't forget the other variable. I'm going to use the x equals negative 3y plus 1 equation. I'm just going to copy it back down from the original problem. And now that y is equal to 1, I can replace the 1 in there and do some quick math. So x is going to equal negative 3 times 1 plus 1. And that's going to be negative 2. So there's our second solution. So to wrap this up, these two lines are going to cross at the point negative 2, comma 1. That's the point of intersect on the graph. All right, guys. We're going to have more videos on this, but I hope you're kind of taking away the fact that you got to look for the isolated variable with substitution. I like to call it the bubble method because you're bubbling the variables. And then you got to replace them. Do not forget to solve for x and y. You got to get both variables. Thanks for watching, guys. I'll see you in class. Bye.